Hey everyone, this is Sanskriti Varshanay from Molecular Detectives. Here, I share information about cancer, from the molecular level to things in our daily lives and environment that affect cancer development. My goal is to explain the intriguing science behind cancer in meaningful episodes that will help you understand preventative measures, cancer signs, and treatment methods, and ultimately for you to make evidence-based decisions to minimize the risk of cancer. Thank you for joining me in today's episode, and I hope you enjoy. Blood cancers. These aren't solid tumors. They're diseases of the blood and immune system. In this episode, I'll break down what blood cancers are, how they differ from other cancers, the history behind them, the different types, risk factors, and what treatments exist. Let's get started. Blood is an important part of your body. It makes up approximately 8% of your body weight, and it delivers oxygen, essential nutrients, hormones, and antibodies to the cells and organs in your body while filtering out waste. It's also what maintains your body temperature. Blood is made up of plasma, platelets, red blood cells, and white blood cells. Let me go into a little more detail on these components. Plasma is a clear fluid that carries a lot of important proteins. It's made up of mainly water and also has sugars, salts, fats, and proteins like albumin and globulin, which help with transporting substances and carrying out other important tasks. Plasma is responsible for transporting blood cells, nutrients, hormones, proteins, and waste throughout the body, and it also makes antibodies to fight against infections. Platelets are cell fragments that help in forming blood clots. For example, if you scrape your knee and start bleeding, platelets will travel through your blood to the site of bleeding. They stick to the lining of the damaged blood vessel and they keep binding together to form a clot to prevent further bleeding. This clot is called a fibrin clot, which is what you probably know as a scab. This is the dark red stuff that you may pick on. By the way, don't pick on it. Fibrin helps form the structure on which new skin forms, so it'll naturally come off by itself when the wound is completely healed and the new skin has grown. Red blood cells make up most of your blood, and they're why blood is red. Red blood cells can be described as having a donut shape, except they don't actually have a hole in the middle. They're responsible for carrying oxygen that you breathe in from the lungs and transporting it to organs and cells throughout your body. And they collect waste like carbon dioxide and carry that back to your lungs to get rid of it. How do they do this? Well, red blood cells contain hemoglobin, which is a protein that binds to oxygen molecules. Whenever blood reaches a place that needs oxygen, hemoglobin releases it. Hemoglobin is red, which is what specifically makes red blood cells red and ultimately what makes blood red. Finally, white blood cells help your body fight against infections. They're also known as leukocytes and make up only about 1% of your blood. There are 5 different types of white blood cells, and the most common one is the neutrophil. Neutrophils are like the body's first line of defense, and they protect your body by killing bacteria, fungi, and foreign debris. The other important type of white blood cells are lymphocytes. These also protect the body by fighting cancerous growth and things like bacteria and viruses. Lymphocytes can be further broken down into 2 groups, B lymphocytes and T lymphocytes. B lymphocytes make antibodies, which are proteins that are specific to fighting different types of bacteria, viruses, and foreign material. T lymphocytes help take care of other immune cells and kill tumor cells and infected cells. So you can tell that a lot of components in blood play a big role in protecting the body against infections. That makes sense considering that blood is a very important part of the immune system. Alright, now I'll actually start talking about the part where cancer comes in. Blood cancers occur when blood cells get mutations. These mutations can lead to uncontrolled cell growth and reproduction. Mutated blood cells live a lot longer than normal blood cells because they are less likely to go through apoptosis or programmed cell death. Because of this, these cells crowd places with bone marrow, which makes it harder for bone marrow to make healthy blood cells. If there are too many unhealthy blood cells compared to healthy blood cells, then there are more things being done to hurt the body than to help the body, because the quantity of unhealthy blood cells overpowers healthy blood cells, and therefore their functions. This makes it easier for the body to get sick and harder to fight off infections. According to Yale Medicine, blood cancers usually happen because of white blood cells. They may reproduce abnormally or too much, and this can make an imbalance of cells in blood. Blood cancers make up approximately 10% of all diagnosed cancers in the US, and they're more common in men than women. In children, leukemia accounts for approximately 25% of all cancers. That number is really high. Now, let's go back into the history of blood cancers, specifically leukemia. According to the Leukemia and Lymphoma Society, doctors first began identifying symptoms like swollen bellies, fevers, weight loss, and weakness in the 1840s. Whenever they studied bodies with these symptoms after death, they noticed that they had way too many white blood cells, which they at the time called white blood. From this name, this disease was named leukemia. The subpart leukos means white, and haema means blood. John Hughes Bennett from Scotland was one of the first doctors to notice this. Although he wasn't right, he noticed a lot of white blood cells in a patient with a big spleen. He thought that this was pus, but his work did help build the foundation for understanding leukemia. Rudolf Virchow, a German pathologist, also studied patients with too many white blood cells, and he proposed that leukemia was formed in the spleen and bone marrow, which is where white blood cells are made. He was more on the right track, and what's cool is that he was the first to call this leukemia. In 1877, a German medical student named Paul Ehrlich came up with a new way to stain blood cells so that they could be more easily identified and studied. This helped him see stem cells, which are undifferentiated cells before they become specialized to form specific cells like stomach cells or kidney cells. This helped him learn more about leukemia at the cellular level. Ehrlich continued studying leukemia, and he differentiated the disease based on what specifically the disease affected. For example, he classified lymphocytic leukemia and myeloid leukemia. Lymphocytic leukemia targets lymphocytes, and myeloid leukemia targets red blood cells, platelets, or other types of white blood cells. He also classified acute and chronic leukemia. Acute leukemia involves immature cancer cells called myeloblasts or lymphoblasts, and chronic leukemia involves mature cancer cells. Eventually, these classifications led to 4 types of leukemia: acute lymphocytic leukemia or acute lymphoblastic leukemia, acute myeloid leukemia or acute myeloblastic leukemia, chronic lymphocytic leukemia, and chronic myeloid leukemia or chronic myelogenous leukemia. Towards the 1900s, doctors started using radiation therapy, a new type of treatment to treat leukemia. However, this didn't completely treat patients as the disease would eventually return, and it only helped patients with chronic leukemia. But during World War One, when mustard gas was found to stop blood cells from forming, chemotherapy drugs like chlorambucil and busulfan were made, and they helped treat chronic leukemias. Today, chemo drugs like methotrexate are commonly used to treat leukemia and other blood cancers. As doctors continued to study leukemia and where it happens, such as in bone marrow, they started to try using bone marrow transplants with the hope that they would help the body restore healthy stem cells. This only worked well in animals though, because in humans, the problem was that the body may reject the new bone marrow because it wasn't the same type as their own bone marrow. It's like how a person with type A blood can't receive type B blood because they make anti-B antibodies. However, over time, doctors made improvements in bone marrow matching techniques, which made bone marrow transplants successful and mainly used for leukemias like acute myeloid leukemia. Now, there is a risk, but a considerably smaller risk in using bone marrow transplants in patients who aren't able to get better from just chemotherapy. In the 1970s, chemotherapy became a really important part in treating cancers, especially leukemia. Combination chemotherapy, which is when multiple drugs are used together to fight cancer, was developed from leukemia research, and it greatly helped increase survival rates. In the 1990s, new drugs like Rituxan were made to target specific markers on cells that can become cancerous, like B cells. Rituxan treats people with chronic lymphocytic leukemia and other lymphomas. Also, around the same time, researchers identified that people with chronic lymphocytic leukemia had the Philadelphia chromosome, which is when chromosome number 22 and chromosome number 9 exchange parts to make a short chromosome number 22 that contains instructions that can lead to chronic lymphocytic leukemia. This helped them make Gleevec, which is a medicine that destroys a protein made from instructions from the Philadelphia gene. From this medicine, more specific drugs were made that could target other leukemias. So, although there were many challenges in reaching to the point we have today, and the journey seems like a roller coaster, researchers and doctors in the past discovered a lot of important things and characteristics in leukemia that helped them develop drugs and medicines to combat leukemia. And now, leukemia is a very treatable and even curable disease. I went into a lot of detail on the history behind leukemia. So next, let's get into the different types of blood cancers. I'll go over three main types: leukemia, lymphoma, and myeloma. As I've already mentioned, leukemia is when white blood cells turn into cancer cells. It affects many different types of immune cells, and it makes it harder for the body to fight infections. Leukemia is most common in children under 15. It's diagnosed using a complete blood count test, which can show doctors abnormal levels of white blood cells when compared to red blood cells and platelets. Next, lymphoma is a cancer that affects white blood cells called lymphocytes. This cancer affects the lymphatic system, which is made up of tonsils, lymph nodes, the thymus, spleen, bone marrow, lymph vessels, and adenoids. It mainly affects the lymph nodes, which filter out harmful substances. There are two main groups of lymphomas, both of which can be split further into many subtypes: Hodgkin's lymphoma and non-Hodgkin's lymphoma. Hodgkin's lymphoma includes a type of cell called a Reed-Sternberg cell. This cell is a very large lymphocyte and may have more than one nucleus. Non-Hodgkin's lymphoma do not have these cells. Doctors know more about Hodgkin's lymphoma, and this type is the most common form of blood cancer in adults. Specifically, these diagnoses make up more than 50% of all other blood cancer diagnoses. Finally, myeloma is a cancer that affects plasma cells made in the bone marrow. This disease makes it harder for the immune system to fight infections. Plasma cells make antibodies, but myeloma cells make too many antibodies that actually end up not helping the body fight infections because they make different types of antibodies and proteins that are harmful. Since they keep reproducing uncontrollably, myeloma cells overnumber and overpower healthy cells in the bone marrow, which can lead to bone damage and weak spots on bones called osteolytic lesions. Myeloma can also be called multiple myeloma since myeloma cells can spread to other bones through the bloodstream and impact multiple places with bone marrow. Now that you know about some different types of blood cancers, let's talk for a little bit about risk factors. According to Yale Medicine, doctors and scientists don't completely know the risk factors behind blood cancers, but as of now, we know that genetics and environmental risk factors play a part. Smoking, radiation, and chemicals have been associated with an increased risk of developing certain blood cancers. Specifically, for leukemia and lymphoma, Yale Medicine says that the Epstein-Barr virus, HIV, and human T-cell lymphoma or leukemia virus infections are risk factors. For leukemia, smoking, having had previous cancer treatments like radiation therapy and chemotherapy, exposure to radiation, and breathing in harmful chemicals like benzene and formaldehyde are risk factors. In general, being older, being male, and inhaling dangerous chemicals are risk factors for developing blood cancers. Symptoms of blood cancers in general are fevers, chills, coughing, itchy skin, unusual bruising, swollen lymph nodes, getting infections recurrently, bone pain, loss of appetite, fatigue, and more. There are also more specific symptoms for each disease, but these are the most general and common ones. A lot of the symptoms that I just said sound like symptoms that you can get from many different types of diseases, and sometimes you may experience these without having any disease, or like just having a common cold, like being fatigued, coughing, or having chills. This is what makes diagnosing blood cancers tricky. People may not pay attention to their symptoms because they're so common and usually go away after some time. Or if they do go to the doctor's office, they may get misdiagnosed because symptoms like these can be signs of many different diseases. And getting treatment for diseases that you don't have can be dangerous and sometimes worsen your current condition. In these cases, it's really important to voice your concerns and say everything you're experiencing to your doctor so that they can do their best to give you the right diagnosis and an appropriate treatment plan. Finally, let's discuss treatments. Treatments for blood cancers can include common treatments used for many other types of cancers, like chemotherapy, which uses drugs to kill and stop cancer cells from growing and spreading, radiation therapy, which specifically targets only areas with cancer using radiation, and immunotherapy, which activates the immune system to kill cancer cells. Other treatments more specific to blood cancers are targeted therapies, stem cell transplants, and cancer surgery. Targeted therapy uses drugs to kill cancerous blood cells and is most commonly used to treat leukemia. This therapy focuses on targeting only cancer cells, not healthy cells, which makes this different from chemotherapy. Stem cell transplants are usually used after initial treatments And in stem cell transplants, healthy cells are infused in your body so that they can help restore healthy bodily functions to fight cancer cells. This is kind of similar to bone marrow transplants, which I mentioned earlier. Finally, cancer surgery removes lymph nodes affected by the blood cancer, and this is used to treat certain lymphomas. Your treatment, though, depends on the type of blood cancer, your age, the rate of the cancer spreading, and where the cancer has spread to, according to Yale Medicine. Sometimes, if the blood cancer you have is developing really slowly, you might not need treatments yet. And sometimes people may never need it, and they just need to be monitored. This is called watch and wait, where doctors wait to give treatments to their patients with blood cancer unless they really need it. This was an information-packed episode. I hope you enjoyed listening about blood cancers, how knowledge of them has evolved over the decades, the different types of blood cancers, risk factors, and treatments available. Remember that a lot of blood cancers don't have tumors, but they're still cancers because certain cells that characterize each disease start functioning abnormally and they grow and divide uncontrollably. That's it for this time. Thank you so much for listening and stay tuned for the next episode.